A big German software company. Maybe you also want to introduce your company and maybe yourself. So 45 minutes, please go ahead.
Thank you. Yeah, good morning everyone. As Bernard said, I'm from Software AG, and my task there is I'm responsible for all the publicly funded research projects that we do. And this is one of them. Cluster Cloud is a Horizon 2020 project that has recently started, so it's running since January 1st, which means that I will not be able to talk about the results because they're not in there, but I will talk about the use cases and challenges that we are tackling in the project. Before I do so, I will use the opportunity to introduce Software AG a little bit, and I've added some slides just to discuss yesterday what we do in the area of IoT and cloud. So we use the opportunity to add some slides there. Okay, just the company, that's the only slide about the company itself. So we are selling to the large companies. Our customers are large companies. 70% of the global thousands of companies in the world are our customers. Due to the communities that are behind that and the large companies there, we have more than 2 million developers using our systems and more than 2.5 million users. Among the things we offer is the digital business platform. I will not go into detail here. I will just focus on the part that's analytics and decision, because I go a little bit deeper into that. Besides that, we offer everything you need for business and IT transformation. We have large tradition in business process management with all the ecosystem that's behind that, in integration, and we also have in-memory data processing. And as you can see, I mean, we started on-premise, of course. Software AG was founded in 1969, so it's a very old company in the software space. And of course, there was nothing like cloud then. And still, a lot of our customers prefer on-premise deployment, but of course, cloud is coming more and more, and many customers just use hybrid deployment. Now, I've shown you the digital business platform, which is the whole thing, and we cut off parts of that and give it another name. One of them is the big data streaming analytics platform, and you can read the statement from Forrester here. So it's not just the CEP. APAMA is our CEP engine. It's not just the CEP, but you see it's also a messaging system, it's in-memory processing, it's visualization, and integration with the rest of our products. So you have not just the streaming processing, complex event processing system, but you have the integration into your whole software ecosystem. Yeah, I mean, well, coming from industry, you might know the Gartner quadrants on Forrester waves. This is a Forrester wave, and you see, of course, what you want to see as a company, Software AG, right? We're using this platform together with partners from industry. Maybe the German people know Dürr. Dürr is a very large machine building company, and they are building up an IT cloud, and they're using our software to do so. And equally Bosch, some of you might have heard about Bosch IT cloud, also our software is inside of that. So we have so-called co-innovation partnerships with these companies. And we also have done an acquisition recently of a company called Velocity, who are dealing with device management, so they are going deeper to the real hardware than we did in the past. So now we can provide the whole processing chain from the sensor, from the IoT device to the business processes. Showing that in this picture, so we have the devices here, we do all the integration stuff, we can do a lot of analytic stuff, and then we have the interfaces to the business software, to the processes that can also run our systems, of course, and all the whole world of companies. So that's about software AG. Just a very, very short introduction. If you want to know more, you can just get in contact with me. Now, I want to talk about this Press to Cloud project, and what's the challenge here? Well, we have a lot of IoT devices. Here I took the mobile phone as just a placeholder. Of course, there are any kind of IoT devices we're talking about. And well, the common way of dealing with that is to do some processing, maybe on an IoT device, and then you send data to the cloud, and something happens in the cloud, and the real value add happens. And then comes fog computing, which means, well, here or anywhere between, you do something. And that's exactly the point where Press to Cloud is putting its emphasis to decide situation, depending on the situation context. Do you do your processing here or here or here? Just do you distribute it? How do you scale it, the distribution? That's a very, very rough overview. Now, going a little bit more into it. The reason why we care about dynamic distribution of processing is that change is inherent in big data, of course. You all know these 3 V's of the multiple V's of big data. Volume, variety, velocity. And in the use cases that we consider, and I will go to the use cases later, in these use cases, it's inherent that volume changes with time, and then velocity changes with time, and variety also might change depending on time, situation, context. And that means while you normally, in our use case, would prefer to do as much as possible local processing because of bandwidth and response times restrictions, you don't want to go to the cloud every time. You might have situations where the volume is just too much or velocity is just too much for the processing power of the device. Or you have some requirements on the combination of inputs of the IoT devices that just occur from the situation and that you cannot fulfill on the single device. So changes in that sense can happen in the incoming data streams, of course, in the quality of service that is either delivered or required, and the speed of changes in the data streams. I will show you some examples for that. And of course, in the status of the processing unit. For example, your mobile device might run out of power or whatever. So, and the overall objective is the dynamic orchestration of these distributed processing nodes to manage these sudden changes, and of course in an automatic fashion. So the vision is, in this project we developed a distributed and dynamic architecture for proactive cloud process management, which means, of course, somehow foresee the change happens. Reaching the extreme edge of the network, so it's not just cloud and IoT, for efficient real-time big data processing. Who are the potential users of our solution? It's big data solution providers, and 3 of them we have in the project, so we can experiment with them, that seek to optimize the resource utilization, and of course some quality of service requirements. So what's the vision of change vision of the cloud. Some, in the real-time big data, some change occurs. And that affects the data-intensive applications, of course. So we foresee that the whole system changes in a self-adaptive way, which means that we have a processing architecture that is flexible enough to cope with that, and that changes dynamically with change in the data and the data characteristics, and not just that we react, but that we also do proactive changes, including the edge devices. The need for that and the challenges we are facing are best illustrated by the 3 use cases that we have in the project. So the first one is from a world that we typically don't interfere with. Well, we all use it, but we rarely think about it, at least in my company. It's a journalism use case. And if you consider the changes that have happened to journalism in the last decade, well, we all might be used, at least the older ones of us, might be used to have broadcasts. You have news, let's say every hour, and it's just one channel and you watch it. These times are common, of course. Yeah? We're talking about multi-channel. We are not talking about only the broadcast agencies providing news, but everyone. There's a lot of freelance journalism, and they are just where the interesting things happen, or they hope to be there where the interesting things happen. And if something happens, they record it and they broadcast it to everyone. Everyone can consume multiple channels. And there are companies that somehow combine these channels to create more or less real-time, multi-channel information that you can consume. And the next step is, if you watch that and you say, oh, there is someone, let's say it's a soccer game, yeah? There's someone recording the soccer game and live recording of that. And I want to know how does a certain player perform. You could even send the request to this freelance journalist. And if many people have the same request, yeah, he might react. So it's an interactive relationship between the journalist and the consumer. That's new in this. But that has, of course, consequences consequences for the processing architectures, for the processing infrastructure that's behind that. So, what is the target in this use case? We want to create a media prosumer platform that offers personalized and flexible consumption of real-time stories. And it combines freelance reporting, traditional broadcasting, of course, and social media. Okay, I forgot something. You should see the picture here, but it just shows that everywhere in the world, news are generated, of course. Yeah? If a president is elected in the United States, if there is an earthquake somewhere, if there is some other interesting event somewhere in the world, you cannot predict that. I mean, elections you can. Everything else is unpredictable, so it happens somewhere. And these freelance reporters, they typically have dedicated boxes for transmission. So it's not just the smartphone, they have some devices that have some computing power, but it's also, of course, the me and you having a mobile phone and being in an interesting place or an interesting event, posting information. And this information is then typically posted to a cloud, but a cloud that's somehow related. So it might be related to location, near, yeah, physically near, or geographically near, or it's just your preferred cloud or whatever. So we're talking about multiple cloud installations, multiple cloud instances. And of course, if you want to consume information, you have to consume it from every of these clouds. Which means that you have distribution also, you have multi-cloud system. These services that we want to provide, of course, include the contribution of contents, the distribution of contents, and the management of the services. As I already said, I mean, LiveView, that's a company who represents this use case in our project. They offer these services to combine news from different channels and provide the most interesting one to you. Also to do some verification of news, to prevent fake news, etc. The typical devices for the consumers are mobile phones, and as I said, they can also contribute to their prosumers using their mobile phones, and they also have these mobile packages for transmission for the freelance reporter, so that's more advanced, more professional. Over multiple connections, I mean, typically here it's somehow wireless. It goes to clouds and is output to different channels. And of course, in this case, it's clear that you need somehow an optimization of the cloud resources. Not just to provide the timeliness. I mean, of course, you don't want to see news that's 1 hour old. You can see it now in real time, not hard real time, but in real time that we talked about yesterday. And you want to reduce cost, of course. You don't want to waste resources. So the challenges, the technical challenges that they are facing here, and we have to cope with this, they have to do the video transcoding somewhere. They have to do the web real-time streaming, the authentication of content, so to do some verification, and some augmented reality-oriented processing that's used for presentation of the news. Yeah, if you do multi-channel, you somehow, of course, want to combine the different streams. So that's the computing requirements they have, and the system should somehow help them. Yeah. The second use case is surveillance. So we're talking about physical security. This is a use case that's from a Cyprus company, and the Cyprus City cooperates with that. They have some thousand video cameras doing surveillance, and the police there also use these UAVs. And of course they have to combine data streams. And well, in a normal day, there's nothing interesting happening, so you don't have to combine many data. Yeah? Everything's normal, people are moving on. These UAVs are not launched because there is nothing to watch. Yeah? So you don't have too hard processing requirements. But if something happens, yeah, there's somehow a crowd gathering or whatever, yeah? Then of course you have an increase of the data you have to process, and also a more real-time need. As I said, they gather video streams, and they do all the things we don't like in Germany. And typically they have this video, they have the video devices, they have so-called regional processing units that combine the input from various video devices and somehow process that. They have a cloud, and they have a control room, and of course in the control room you can say I need more data from there, from here. And this regional processing unit, they have there's video analytics, there's audio analytics. It's also has some media content management, and they also combine information from sources like social networks. Now the challenges that they face is video transcoding again, audio analytics, and of course, I mean, why do you do surveillance? You want to detect security-related defects. And of course, typically you cannot detect it from a single device, from a single combination of yeah, you see some systems that are somehow used to combine data and process data. And the third use case here is a logistics use case. They somehow control a fleet of 30,000 or more trucks. And of course, every truck today has a device on board that somehow records the data and sends the data to the cloud, or what is happening in this. And today, these data in the cloud are used to do some analysis, maybe even some prediction. But what's not happening at the moment is somehow truck-to-truck communication, truck-to-truck fleet intelligence. Things like that. Let's say one truck has a problem and the closest truck is somehow informed automatically to go there and provide some help, let's say to change a tire or take over some critical load or whatever. And of course there's a lot of sudden need for change if something happens on the road. The road is blocked, or some weather conditions change or whatever. There's also a large variety in the need for processing, and of course it's also some form of real time. And you have to inform the truck while it's driving. They're generating data currently when they're driving every 200 milliseconds. And of course, here you have, as well as in the journalism case, you also have the issue of bandwidth, which is varying, of course. Yeah? I mean, the journalist might be somewhere in the jungle, yeah? low bandwidth probably, and the same happens here. No jungle, but if you drive through Germany, you notice that network coverage is not very good everywhere. So also the bandwidth issue here. And you have to somehow cope with that in a dynamic fashion. So these are the use cases that we want to address in this project. As I said here, the challenges are smart sampling, semantic enrichment. It's, for example, contextual information about weather conditions, road conditions, etc. And something they call social context identification. Which means you somehow track the condition the drivers. Not going into detail here. And of course you want to detect anomalies automatically, which somehow holds for all the cases that I just. So what are the functions that we want to provide with this Presto Cloud platform? It's of course processing at the edge, but including the cloud computing infrastructure and the edge resources, and possibly some resources in between. The orchestration of the distributed processing nodes, just to cope with the sudden changes in data. And of course, the systems should be self-adaptive. No need for human intervention, of course. And not just self-adapting, but also proactively predicting and reacting to upcoming changes. Well, the architecture, as I said, the project is running for 5 months now. So that's the first sketch of the architecture, which of course is subject to change. As it is very small here, I magnified some components. These are, let's say, from my point of view, the critical components. The workload prediction, I mean, one thing is to recognize that something has happened, but of course it's more useful to predict it. And then to have a recommendation for resource adoption. which means, of course, you scale out to the cloud, or you do some scaling in the cloud, or you involve multiple cloud systems, or you do everything on the edge, or whatever. Yeah? And of course, if you have something like that, you need, as a next step, you need deployment that somehow does what the recommender recommends. And of course, you have to, fragmentation means decomposition. So you have to decompose the computing tasks somehow to parts that are executed on the edge and executed out. And yeah, that's something like that's called the project. And then what you get, target, is a dynamic real-time processing network that somehow distributes the load over the processing nodes. I mean, that recommends that, and of course, then you need a dynamic deployment that installs the necessary functionality. So that's the target architecture. And what do you need to get there? You need somehow virtualization of the network. You need dynamic monitoring, of course, on all levels of the big data processing. You need situation-aware and context-driven adaptations, leading to recommendations, and then you have to somehow assess the recommendations and then deploy. Getting a real-time mobile stream processing that uses all the devices in the optimal way. And you want to get at the proactive or I should say going into detail for these technical objectives, the network virtualization, I mean, that's already existing, but we're going beyond the state of the art in these points. Yeah, you can read that yourselves, but I just want to stress some of that. Security is, of course, in a dynamic world like that, security is even harder than the static world, so we have to do something there. In particular, also concerning firewalls and access detection rules, if you have such dynamism. Yeah, you have to control the external controllers. And of course, you want to obtain statistics to do more proactive prediction and better prediction. Then the dynamic monitoring. What are we doing here? What is beyond the state of the art? To monitor this whole distributed real-time processing architecture is not straightforward. And combining the predictive capabilities to recommend the resource adaptations is also not available yet. To do some prediction like that, you better have a meta model for that, so that you can base your predictions on some foundation. And yeah, that might lead to a new semantic-based model for distributed processing architectures. Yes, and I mean, you do all that to enable the real-time changes of the processing pipeline. This context-driven and situation-aware adaptation recommender system. The new things that we do there is we combine the predictive capabilities that we derive with the ability to recommend the cloud's resource adaptations. I mean, you predict that something happens and quantify it somehow, but then you have to do the next step. What does that mean for your resource requirements? And which part should you do in the cloud? cloud and which cloud and what do you have to deploy there. Another model is required here. We call it the big data situation meta model to model these situations, and of course we have to propose some algorithms for effectively and efficiently devise these productive actions. Yeah, we want to come to a real-time mobile stream processing, and of course we have to investigate the concept of bandwidth and media utilization. In this context, something that's not really relevant today. I mean, there is, of course, people know the need to do so, and there are some approaches, but we can certainly go into that. And to do the decision whether we do the computation on the edge in the cloud or some approach. Yeah, acceleration concepts for local analysis, global analytics control, etc. And finally, the product of cloud computing. What's new there? Somehow want to provide a workflow catalog system for these deployment workflows, and not just have a scheduler, but a scalable scheduler. So the scheduler itself has to adapt to the cost of the workload. And yes, of course, as I said, we have the situations where multiple cloud providers are involved, yeah, they somehow have to be connected, and you even might face the challenge to decide which cloud is the best for this. So yeah, that's about the technical objectives of Presto Cloud. What we as Software AG already did, just as a remark why we are in this project, we did something we called CEP recommender, and that's just a distribution of a single CEP query processing instruction over multiple devices. So our ARMA runs on large devices, small devices, so we can run it on Raspberry Pi, you can run it in the cloud, and on any device in between, of course. And the idea is to have some query and then somehow fragment it into several parts shown here, and then distribute these parts over the processing. So that's what we did in a previous project, FP7 project, and we integrated that into an IDE. So we have some experiments or some experience also with this distribution processing logics. And we also have some bad experience there. I mean, it's, the algorithms themselves, you can derive a lot from database optimization. But the criteria for distribution are not that easy. So, as I said, bandwidth might play a role, we can consider that here. And yeah, you also have to consider cost functions because, well, in all the experiments we did not really show an advantage of the distribution, which is caused by the fact that we have high bandwidth between processing nodes and large processing nodes in that case. So in that case, distribution did not really bring advantage. In Presto Cloud, the situation is different, so we hope that get better experience there. And of course, this is just one building block of the Presto Cloud system, not a sheet. And of course, yeah, some remark that has to be made here. I said we are doing surveillance, we are doing journalism, and we are doing truck monitoring. These are all things that somehow involve personal data. And of course, that's another point we have to consider in the project. A non-technical, but nevertheless very important point. well, I said non-technical, which is not true, because the regulations that we have in this area somehow restrict what we are allowed to do technically. Yeah, for example, audio processing in Cyprus, use case is one, is restricted by law. So you cannot do that in the cloud. You're just not allowed to do so. Yeah? Which means that you also have to consider these constraints in distributing process functions. So it's not completely independent. But of course, I mean, all of you who have had an EU project know that the EU, of course, looks very, very carefully to these issues, which is right, and you have to fill in this table every time you apply for a project. And you see, yeah, that there are three yeses here, which means that we have to be very careful to also cope with the regulations here. Just who is part of the project? Software is coordinator of the project. The three use case partners are Slovenia for the CDS Mobile in Slovenia for the logistics use case, the Cyprus company Edites for surveillance, and two Israeli companies for the media use case, LiveView and Technologies. We have, of course, some research partners from Greece, France, Slovenia, some technology providers, in addition to software engineers selected here. Ubitech, who was also shown yesterday in the Beacon project, and this and yes, I said software is coordinating. So that's it about Presto Cloud. Thank you very much for your attention.
So you have time for a few questions? Yeah, Costa?
I wanted to ask about the workload prediction. What is the main methodology for predicting workload?
Yeah. I cannot answer that yet, as I said.
Okay, next question. The adaptation actions you intend to apply, what is the range of adaptation actions you're considering? Adaptation.
Adaptation. What's the range? Sorry. The range is, well, that's not very easy to answer. Typically, in all the use cases, you're interested to do as much of the processing as possible on the edge, for various reasons, bandwidth being one. But in principle, everything that is allowed to be transferred to the cloud should be considered to be transferred in the case that there is some resource restriction or some process need that cannot be fulfilled in the edge. In principle, you want to mirror all the functionality that you have on the edge plus some additional functionality. That means combining things from the edge and the cloud. I don't know whether that answers your question.
I'm asking in relation to the autonomic features, and I saw the autonomic component over there. I assume this ties in with some adaptation action to achieve certain goals. I may have missed it, actually, you may have said it, but the autonomic functionality, what is exactly the goal? To adapt to workload, I guess, right? The workload changes?
Yes. To adapt to the workload changes, to achieve as much as possible the required quality of service, and to lower the processing cost of this.
Okay,
so it's the usual functions.
Predicting surges and adding capacity, basically, right? This is pretty much.
Yes.
Okay. This platform is software AG's contribution there, or is it?
No, that's a joint.
Full platform project. Okay.
But you can also react to bursts in workload by, for example, distributing that what you process in the CEP on different nodes, right?
Yeah.
You not only have to provide new resources or get rid of resources. You can change the processing, right?
Yes, I mean you should use all the resources that you have anyway. Sure. Yeah. So as I said in this video surveillance use case, there are local networks of video processing systems that exist anyway. And of course you can distribute load over the nodes in this network. But there are cases where this network is not capable of doing all the computations that you need, or you have to combine more of the data with other networks. So the reason for sending more data to the cloud is not that you cannot just process them, but that you need them for a certain special purpose computation in the cloud. That's not the usual operation, but that's required.
Okay. Daniela?
In this live reporter case, you said that they are planning to do some check against fake news or whatever. Is that automatic, or is it about people? And does this context awareness come in? So, like, this video stream cannot come from this place because the temperature there is much higher. Or what? Do you have some ideas on that?
That's probably the valuable knowledge of the use case partners. So they don't tell us the rules. They have the rules.
Is it automatic rules, or
yes,
is it people looking and saying?
I mean, the first level is automatic rules. And I mean, they get so many streams they cannot look at any stream by unit. So if there is some suspicious source, well, typically they will just discard it. Maybe there are special cases where they send it to some room operator to do that, but typically you cannot just do that because of the law. So they have an automatic system that somehow, and don't ask me how, because that's, as I said, that's a company secret, but they somehow provide means to detect suspicious sources.
Okay, so thank you for that. Now we get back to our first speaker.
Did you send
it?
Yeah.
So he sent his slides to this computer and this seems to work. So I hope that in a few seconds we are ready to go.
Let's see whether it works.
So we all remember what he told us about Huawei and what his job is, so he can directly go on where he was stopping 40 minutes ago. We don't lose any time on that. Okay, that looks okay.
My presentation was good. Just tell me when the next starts.
Good, you can. Next. So I will talk about 4 different topics. I will start with the OPC, the public cloud, so you have an idea of what type of public cloud we already have in Europe.
I guess you should speak a little bit louder. Yeah.
So the first slide is about Open Telecom Cloud. So this is a public cloud available in Europe and is being provided by Deutsche Telekom and TCs. So here the idea is to start to have in Europe competition to Amazon, for example, and Google and Microsoft, where the data is kept in Europe and follows European regulation. The platform provided is not as sophisticated as Amazon. They are really ahead of competition. Microsoft is getting very close to Amazon, and can still need probably a couple of years. Amazon number 1, number 2 Microsoft, number 3 Google, OTC I'm not sure if it shows up in the rankings, but at least for Europe it's quite important. So the platform, just one here. So all these platforms that you see, so you can go to the website and you can even request access to have some credits, and you can ask for your VMs, for your storage, same thing as in Amazon. So this platform has been, it's provided by Dutch Telecom and T-System, but it's being engineered by Huawei. So we do the development of the software and also the hardware. So the servers, data storage, everything is supplied by Huawei. Huawei has quite some interesting equipment. I'm always surprised. I work for Huawei, but still I'm always surprised the type of equipment that they have and seeing all those servers and firewalls and really heavy equipment. It's quite impressive. The approach of Huawei was a few years ago they had their own private cloud, and it was developed by Huawei. Everything was, all the code was developed by Huawei. They took a decision a few years ago to start using part of this cloud to have a management layer, which is OpenStack. OpenStack, it's open source. You can download it to your laptop. If you have 8 GB, you can even have your own mini micro cloud. You can start a few VMs, not too many because your operating system is not handled only with 8 GB. If you have 32 GB, you can even have 4 or 5 VMs running. And it gives you a feeling. It doesn't take too much time to install. Maybe in a couple of hours you can have the thing work. You see here all the releases. Every 6 months there is a new release. We are, in Munich, we are testing now Manhattan, which is the latest release. And it has just some context. It was triggered by Rackspace and NASA quite a few years ago. A lot of companies use OpenStack internally. So if you are a medium-sized company, maybe you go for OpenStack and not VM. Why? Mainly because of the cost. So OpenStack, it's open source and free. It's not as free as you would like it to be because it has cost of deployment. You need to have a few engineers and good engineers because it's actually quite complex to install. When it's running, then you don't have costs. Huawei took this approach. There are several reasons. One of them is I think people and